Hey guys, I'm Daniel, and the question we're going to be doing today is a certain first order reaction, A yields B, is 25% complete in 42 minutes at 25 degrees Celsius. What is the half-life of the reaction? Okay, so let's look at the question, and let's determine what's important and what's not. Alright, this 25 degrees Celsius, you know, it might confuse you a little bit because you don't know if you have to include it or something, but it's actually just pretty much a standard state at which a reaction is completed at. It's kind of like the regulation or something. I don't know, but anyways, it's not important. All right. So everything else is important. We're going to be using this time and this completion rate to calculate our answer. All right. And so just so I don't confuse anybody, before I begin, this is the calculation for the concentration of a certain reaction, and this is the half-life of reaction. Okay. So just keep that in mind so you don't think both of those should be used. Actually they are, but not at the same time. So if you look at our reaction, we're not given any certain any starting concentration, any final concentration. We're just given the percentages at which something is complete. Okay. So when you're given a percentage and no actual values, you should assume that your initial concentration is 100 molars, and whatever the final concentration is according to this completion rate. Okay, so first of all, let's label our initial concentration. A naught is equal to 100 molars. Okay, just for the ease of calculation. Okay, now our A final concentration of the same compound after the reaction. Since the reaction is it's giving us a time for a 25% completion rate. Okay, we're gonna label our A final as 75 molars. Okay. Now, it's given us time, okay? So our time is going to be equal to 42 minutes. Alright? So now let's plug in these values into our rate equation to find out what the K value is. So we can plug it into our half-life equation to determine the half-life of the reaction. Alright? So let's go ahead and start plugging things in. So the ln of AT, which is 75 molars, okay, so 75 molars, is equal to negative K is still unknown, times T, which is 42 minutes, plus ln of A naught, which is 100 molars, plus ln of 100 molars. Alright, so the first thing we should do here is move this ln to this side of the equation. Alright, so we're going to have the ln of 75 molars over 100 molars. And by the way, this is just a property of ln. When you're subtracting one ln from the other, you can put it like this, just to make it easier to plug into your calculator, I guess. And you can try it out yourself. Ln of 75 over 100 is the same thing as ln of 75 minus the ln of 100, just in case you don't believe me or you want to make sure for yourself. But anyways, let's get on with the problem. Alright, so this is equal to negative K times 42 minutes. Alright. Now let me plug in, actually let me do that calculation. Ln of 75 over 100. So ln of 75 over 100 is equal to negative 0.2877. Negative 0.2877 is equal to negative K times 42 minutes. Alright. So let's divide this 42 minutes to isolate K. So 42 minutes divided by that, 42 minutes. So that answer divided by 42 gives us negative 0.00685 is equal to K. And that's, actually let me write the units down. So that's going to be minutes to negative 1 equals K, or negative K. So once you cancel out that negative in front of the K, it becomes positive 0.00685 minutes to negative 1. So just in case you wanted to write all that work down, I'm going to be erasing soon. So if you feel like you want to write all that down just for studying later on, go ahead and do that. Pause it right now so I can erase. So now we're going to be using our half-life equation to determine what the half-life is. Okay, so we found K. Okay, let me write it up here just in case you like it more clear. So K is equal to 0.00685 minutes to -1. Alright, so now let's plug this into our half-life equation. So ln of 2 over 0.00685 minutes -1 is equal to, so ln of 2 divided by 0.00685 is equal to 101.2. And that's minutes. Okay. Because when you have a negative exponent on the denominator, you can throw it to the numerator side to make it a power of just 1 instead of -1. Alright. So this 101.2 minutes is going to be our answer. And if you're doing the same problem set that I am, the letter answer is going to be E. I hope everything was clear. I hope you're able to understand everything. Thanks for watching. I hope you found it helpful.